Get
0.
0. If you're used to saying 2 pi, that's typical because we don't usually talk about 0, except the arc cosine doesn't go to 2 pi. Okay, it starts at 0. So 0 is the answer. All right, everybody do this one. The arc tangent of 0. Now you got to think of y over x. So it's y over x. What do you know about y over x for it to be equal to 0? What?
0 needs to be on top.
Yeah, y has to be 0. X can't be 0. Y is in the numerator. Y must be 0. So where is y 0?
Oh wait, no, that's 0.
0. Good. Good job. Okay. It's just the backwards of what we're asking. What's the cosine at 0? 1. What's the sine at negative pi over 2? Negative 1. Okay? Just think of it backwards. Alright, we're catching on? Everybody get your calculator. We'll come back to this again. Everybody get your calculators out. This is example 8. You want to be in radian mode here, because I'm asking for radian measure. If I'm asking for degrees, or if I'm dealing in degrees, then I know to be in degree mode. So I know students when to use which mode. We're in radian measure, radian mode. I want the arc cosine of negative 0.75. So this is just me warming you up to be able to solve some application stuff. Application stuff is pretty easy in this section. Anybody not have their calculators with them? At the moment, I'm making up your pre-test for the chapter. Looks like we'll use calculators this time. Just remember, your calculator is only your friend if you are smart enough to do it without the calculator. If you're depending on your calculator, you're in trouble. 2.4189.
We put 4 decimals.
Yeah, if you're finding radian measure with numbers, just put 4 decimal places. If you're finding degree, just round it to the tenths. Okay? Alright, let's do this one. Example 10. The arc sine of 1/3. Now, you should put it in the calculator like this. I don't want you to put 0.3 because then you just rounded it if you did. Make sure you put the in parentheses in. Yeah, these are the baby steps to the application.
0.3398.
Yep, good. 0.3398. Anybody not get either one of these two and need some help? So this is just teaching you how to use your calculator. Now, let's apply it. Example 16. Here's a right triangle that's drawn strangely on purpose. 7, 18. This should look somewhat familiar to you. And here's theta. It's a little bit like yesterday's. Okay. This is as applicable because sometimes we need to know how far away something is, and we can use trigonometry to do it. It's hard to use proportions because sometimes things are so far away, we're talking miles away, that we can't use proportions. But if we know the height of something and how close we are to another object, it's possible we can use trigonometry to figure this out. And sometimes we need to know the angle versus the length. So you're going to tell me the angle, the degree of this part of the triangle. In construction, we need to know the exact degrees when we're doing major projects, okay? So I want the exact degree of this angle. So this is algebra 1. What have I been given compared to this angle, compared to theta? The opposite leg and the adjacent leg. Which trig function uses opposite and adjacent? Tangent. And that's the beginning of this stuff. That's how you're going to set up every right triangle. You have to ask, what have I been given? So the tangent of theta, notice I do not have the arc tangent. This is just the real normal function. The tangent of theta is the opposite leg over the adjacent. You say, that's real great, I don't know what theta is, so I can't take the tangent of it. That's right. You don't know what theta is, you can't take the tangent of it. But you can switch things around and do the arctangent of 7/18 to get your degree. So you guys tell me what you get. Wait a minute. Are you finding degrees? Yes or no?
Yes.
What mode should you be in?
Degree.
Degree mode, thank you.
505.
Yep, 21.3 degrees. Let's round our degrees to tenths. We'll round our radian measures to 4 decimal places, okay? Or whatever the book is asking. If there's instructions in the book, then follow what the book says. All right, that's 16. There's your first application. Not really a story problem, but we're getting there. Example 18. Here's a nice, neat right triangle. Short leg is 30, your hypotenuse is 70. You guys tell me what the degree of, let's do this one, that angle is. So I'll give you guys a few minutes to figure it out. Use your basic trig functions to figure it out. Opposite, adjacent, hypotenuse. That's pretty big, man.
Yeah.
That's all right. Easier to find that way. Don't run out of room. Write neatly. Because in May, when you take the exam, you're going to be like, that'll be all smudged over.
What was I thinking that day? Was I half asleep?
You're going to get back to the second page and you'll have this much, you're going to be able to start writing real small.
It's like
I will give you a second page if you have to have one. Just try not to get that far.
next week.
We have lots and lots of stuff to put on there. Okay. Just kind of curious. Abby, did you get there?
Nope.
Nope? All right, Abby. It's all you. Let me ask you this, Abby. What have you been given compared to theta? What sides have you been given? What are their names? Opposite and
Oh,
hypotenuse. So which function are we going to use? Remember? We do it like this. SoCal. So which one are we going to use?
Oh, sorry.
Sine. Good. All right. So the sine of theta is 30 over 70. And again, I can reduce that to just 3 over 7.
Oh.
You can use 30 over 70 if you want. It's going to give you the same answer. All right. I don't know this, but I do know the arc sine of 3/7. Is what? Who did it? Who wants to answer? What'd you get?
25.4.
That's right, 25.4. Good job. You want these on the quiz, don't you? Oh, good. Because ones like these are on the quiz. Okay? I think.
Yeah, probably.
And ones like the first few examples are on the quiz as well. Okay? All right, example 22. Everybody do this one. Let's just see if you can do it. Sine of theta equals radical 3 over 2. That's something like what would be on the quiz. Notice it's not the inverse. And there's a reason for putting this on there. Everybody stop for a second. Oh, with the radian in terms of pi. Listen, I'm asking for the sine of theta to be radical 3 over 2. I'm not asking for the inverse. Now, you may use the inverse to figure this out. What I want is all the solutions where you get radical 3 over 2. So since I'm not asking for the inverse, you're not bound by this. You are now back to looking at the whole unit circle. So there's going to be more than one answer for this. There's 2 answers for this. Okay, now begin. It's when you're asking for inverses that you're bound by this information. it's going to be in the first and second quadrant because y is radical 3 over 2 in this position, and y is radical 3 over 2 in that position. You need to think like this because in chapter 7 you do this a lot. You got to give me multiple solutions. Okay? So what you're thinking of, the y value is right here, square root of 3 over 2. Where does it hit the circle? In those two positions. Alright, so this would be the last of those 3 blanks in the first quadrant, and the first of the 3 blanks in the second quadrant. So what is that?
Pi over 3.
Oh, I'm sorry. I went backwards. 3. Went backwards. Same thing here. Pi over 3, pi over 4, pi over 6. What's this one?
2 pi over 3.
Okay, good. 2 pi over 3 and pi over 3. So what is 2 pi over 3 in degrees and pi over 3? Good. 120 and 60. So there's your, that's what I want. And you can go by what it says in the book, that's fine. But if I'm asking for the degrees, if I'm asking for theta, it's usually the degrees that I want. 60 and 120. Yeah.
Are you gonna want all 4 answers?
No. Just the, if I'm asking for theta, I'm asking for the degrees.
Okay.
Okay? And just look in, you got the answer, so just look in your answer book to see what they're doing and just following. But that's why it's the degrees. But I just wanted you to understand, you get those degrees by looking at the radian measure. Okay? One more. Alright, we'll do the a little more complex one. This is example 28. The tangent of the arc sine of 4/5. What are you going to do first? Say it. What's inside the parentheses? Are you finding degrees? The arc sine? You're not?
Yes.
First of all, what is the arc sine of 4/5? What did you get?
53.1301.
53. Yeah, 0.1 degrees. Now, did you get that? Do you have a calculator? Did you get that? Did you take the arc sine of 0.8? Okay. So 4/5. Now watch. Watch this, everybody. What is the sine? It's my y value, right? The sine is what? Opposite over hypotenuse. What's this? Adjacent, but what is the value? 3, 4, 5, right triangle. It's positive, so this is right. What's the tangent of theta then? Opposite over, oops, adjacent. What's 4/3? What's the tangent on your calculators of 53.1 degrees?
1.333328.
This one is more exact than what you just told me. Because this was all done with fractions. Fractions are exact. Anyway, my point is, I'm not asking you to do this. I'm showing you this because in the future we can do this, and you're going to need to do this to solve some things. Today you're just going to take the arc sine on your calculator of 0.8, and then take the tangent of that, and you get 1.3. Okay? Okay? All right. Assignment. Page 467, 3 to 35, 37, and 41. This is odds, guys. Have at it.